You're listening to the Modern Mainframe, BMC's intelligent Z optimization and transformation podcast, covering the latest trends and issues on the mainframe and how BMC AIME and BMC Compuware Solutions can help you build a mainframe-inclusive DevOps toolchain. Hello, everyone. Welcome to the Modern Mainframe. I'm Matt Dallaire. In today's episode, we're going to be talking about shift-left testing on the mainframe, what it is, why it's beneficial, and how to shift left with your own testing. Our guests today are BMC Lead Product Manager Spencer Hallman, Senior Product Manager Paul Allard, and Lead Product Manager Stephen Solomon. Gentlemen, thank you for joining us today.
Thanks for having us, Matt.
Thanks.
So in today's digital economy, people are conducting all types of business online, and users expect to have their needs met with new apps and services without issues like bugs or downtime. They're expecting constant innovation. And of course, the apps and web services dealing with a variety of industries, from banking to insurance to retail to healthcare, depend on the mainframe to form their digital backbone. In fact, the results of the 2021 BMC Mainframe Survey show that 45% of mainframe champions, which are defined as organizations where mainframe investment is increasing or MIPS are expected to grow, need faster updates of core applications to keep up with business demand. And 43% want improved quality when developing or making changes to mainframe applications. So clearly, mainframe organizations are feeling a need for speed to keep up with market demands. But speed isn't enough. Customers also demand quality. So how does this change in customer expectations affect the mainframe? Spencer, I'll start with you.
Yeah, I think we first have to think about who is the customer, what customer expectations, who's creating these expectations, and there's the internal and the external customer. And the external customers, putting those expectations on the teams that are developing the front ends, the web apps, the mobile apps. And then those development teams are putting those expectations back on the mainframe back end, because they are going to require, time and effort from those teams to put those new features in front of the customers. Steve, you look like you were going to say something there. I didn't want to step on your foot.
Actually, on the need for speed and new services, something to keep in mind here is the mainframe is a core part of the IBM hybrid cloud strategy, and data is core to that. So your applications that run on the mainframe, the data that needs to be exposed, whether it's mainframe-hosted applications or even web-based or phone-based applications coming in. So all of these changes help drive your business. So that's why it's really important that we focus on how to be innovative, how to make sure that you don't have any wasted time, and that your agile processes have a modern DevOps toolchain.
So many organizations are testing their code changes manually. What is the problem with doing it that way? Paul, can you expand on that?
Sure. With a manual process, there's always room for a lot of errors. It's kind of a process where you have to make sure you have the right files set up, your database set up. So there's a lot of setup involved. There's a lot of a developer looking at the green screen saying that, we really have to make sure we have all of our ducks in a row to do that test case. So there's a lot of manual intervention involved. With automation, we can create a test bed, and when we make a change to the code, we can actually run that test bed against that current change. We can kind of remove a lot of that manual process and use the automation part of it. So that's going to save a lot of time for developers.
I think the other thing too is that, you fix a bug once, right? And you create a test case to test that bug, to make sure that what you put in there fixed it. You want to keep testing that, and manual testing really doesn't allow for that, because it would take forever if you think of all the bug fixes that go into a different application. But with a tool that you can create these test cases and then put them into a modern DevOps pipeline, they just get tested automatically. And maybe it takes a little longer the more test cases you add, but that bug won't resurface without you knowing about it.
And that lends to the consistency of the testing, right? It makes it so that everything is tested the same way.
Yeah, absolutely. And, when I was more of a product owner, that was one of the requirements of the development teams, was that every time they put in a new enhancement or a new fix was to develop a unit test for that, or test for that could be run automatically. And that way we knew that, we could move faster and we could put out code with great certainty that it was good, high quality.
And I'll second that. So I've got 11 products, and we just could not deliver every quarter, every 3 months with manual testing. With the automation that we have and the scope of the products we have and all of the functions that they do, there would be no way. It would just be inconsistent. It would introduce too many bugs. And we do unit testing up front where we do build a lot of the test cases, but we do very large regression testing. And that just couldn't be done manually these days. So very, very important to have good test suites for the functionality that's core for your business application.
So it seems that the risks of manual testing are quite high with the time, with bugs getting through, inconsistencies, etc. So why are organizations still testing manually?
I don't think they have the tools or the tool set to automate their testing. They rely on, sometimes they push it to a specific testing group, and that testing group will say, okay, what are we trying to do here? And then they'll walk through the application and test it manually that way. But, ideally the best way of doing this is to create these test cases and automate how they get executed.
Yeah, I would agree, Spencer. A lot of times what we've seen in the past, companies I work for, is you would, as a developer, you would have to kind of write your own manual test cases and eventually hand those off to maybe another quality assurance or a business analyst to kind of run and verify your test before it gets implemented. So there's a lot of manual process there. If you can remove that and have a tool that can automatically create a test for you and then be able to hand those off, it's quicker for a QA type person to kind of just kick those automated test cases off. There's there's not a lot of setup involved in running that. You go into a IDE and kick off that test case, and it's easy to create the test case, easy to run it. We try to kind of remove that manual roadblock for a lot of the developers.
I also think there's a resistance if you don't have automated test cases today that you think it's going to be a big expense and it's going to delay your work. So if your choice is that your business is asking for something that's important right away and you think I'm going to have to put that off to build test cases, it is worth the investment. So it's one of those things that you deliberately need to make a priority because that is going to save you time in the next release and the next release, and you will be able to move faster at higher quality once you make that investment. But it can be a big investment up front, especially when you first get started, but it pays off tremendously long term.
Yeah, I would echo that, Steve. I remember when we started this, and I was back in my product owner days, I'd say we need to start doing this, unit testing, this automated testing and creating these test cases. And there was a lot of pushback from development initially, like, well, that means you're probably not going to get what you want this quarter because we're going to spend all our time creating test cases. And I called them out on it. And I told them, I said, if we do this and we start down this process, it might be there's going to be investment up front, but the savings on the back end is going to be exponential. And we did see those savings, and we started moving faster and putting out better quality code. And I spent less time on conference calls as a result, which made me happy.
Right. So shift left is a bit of a buzzword in the industry. What does it mean and how does it help with testing and with the overall process? Spencer, I'll start with you again.
Yeah, it's earlier in the software development lifecycle. You should start testing, as soon as you can. When I was a Strobe FTS or systems engineer, we had something from Accenture that said that the sooner you test, we were more focused on performance testing, but, the sooner you find your bugs in the software development lifecycle, the less costly it is to address those. And they estimated that it's like 8 to 10 times less costly to find a bug in development than it was in production. And I asked somebody about that once. He's a partner at Accenture, and I said, is this true? Because, I had been quoting it for like 15 to 20 years. And he said, oh yeah, absolutely. And we talk about that, and we say, and he gave me a figure that was even higher than what we would talk about with our customers. So it is true, that if you can shift left, if you can test earlier in the software development lifecycle, it's going to cost you less money when you uncover these bugs to fix them. So when you're testing smaller things, it's easier to figure out what the problem is when you're testing a smaller piece of code than when you're testing a big monolithic system.
Right. And I think, to piggyback off that, I think a lot of the shift left terminology isn't anything new. A lot of these concepts have been around for a long time, 20, 30 years. But the shift left, like you say, Spencer, it's trying to catch those bugs early. So a lot of people have probably heard the term test early and often. That's kind of been around for a long time. But, if we can unit test that code as we're developing it and really run our regression test that maybe we created from an automation process against that program and catch something, then we can quickly fix it as we're developing it. It's a lot cheaper and easier to fix it, when a developer's already in the code than before it gets out to production or maybe even pass through the QA process and get out to production. Then you got to really bring that program back in and there's some downtime associated with that, and that could impact your business. So obviously it's a lot cheaper to do it in that development process as opposed to at a customer site, or, customer impact. So really that's the whole point of really trying to shift left.
And I'll also add that, the goal of shift left is fix problems when they are developed, when they occur. So if you can fix it during the development stream, maybe in a new IDE to keep problems from happening, that's wonderful and amazing. But you definitely have to get closer to it. And I can tell you the most expensive defects we have are what we call escaped defects that make it into production. And one of the things to keep in mind there is once we find a bug, it's not as easy to get it changed because the development team has moved on. Maybe they created that bug 3 months earlier, and now they finally capture it. You send it back to the team. The team is already working on another project. They've got to go get time allocated. Somebody has to go figure out what the original intent was, maybe understand the code. Maybe it's a different developer that has to go fix it. So the cost is substantial. The farther right it moves, I have always used a 10x at every stage from unit, system, acceptance test to production. But whatever it is, I can absolutely guarantee you I've got a dozen war stories that I can tell you why shifting left is important and will save you a lot of time. But oftentimes you don't think about that is the app dev team who created it may have moved on to a different project. And then it's just that much more expensive to get it rescheduled, get it fixed, and then get it repushed out to production. So the other thing here is the shift left is the faster your timelines. So the more agile you are. So instead of delivering once every 6 months or a year, the quicker you can develop, the easier it is to do that shifting left and fixing those problems earlier. So, it's all part of that agile methodology about fixing the issues where they're created.
Right. And I also think we're starting to see, not starting to see, but we are seeing that most of the bigger companies are now moving away from the waterfall. And that's really where this whole concept kind of comes from, is going from a waterfall approach to an agile approach. With waterfall, you don't do your testing till almost the very end. And that's traditionally how mainframe shops work. But we are seeing that approach moving and shifting left, which means it's more of the agile approach. And that's really how we can move faster and make the mainframe just as fast as the distributed side of the shop.
Yeah, there used to be this flawed idea of two-speed IT, right? So that your distributed teams were agile and they moved really fast because they had to. And then the idea was that, the mainframe guys can't move that fast, so we're going to keep them in waterfall. And then what would happen was your agile teams are moving really quick, but then they would stop because they would have to wait for the mainframe teams to catch up. And it never worked. And I think they finally put an end to that. I haven't heard that term in a long time. But with waterfall too, you wait till the end to do your testing and you're bound to miss bugs than you are with an agile approach.
And don't forget, as part of your testing strategy, to consider your test data approach, right? So, we have several customers that have billion row tables in production. You don't copy a billion rows into test to run a test case. You want to make sure your test data represents what you need to test. And so it's very important that you prep your test data, that you build out your test cases that are efficient. Don't test the same thing 1,000 times, right? Make sure your test case is representative so it hits all of your code paths. And then make sure that you have a baseline, that you know what your test is, and that you have repeatable baselines of data for your testing also. So don't forget your data as part of your strategy.
Yeah, it's a good point, Steve. I know I've worked at large companies in the mainframe area where if you're going to go test, it's quicker to pull down a copy of a production file and run it through your program. You know, you could be testing with 1,000 records where you only need maybe one to hit that particular paragraph. But it takes time to do that. So, and I think we have those kind of tools that can optimize that data before we run that test case. So that's really important too.
It's kind of interesting to note, production may not have all of the options. You may have added recently a column that is on your orientation. Are you male, female, other, non-binary? You may not have all of those flags set in production. So that's what I say. Make sure that, when you're doing test cases, make sure that your data runs through all of the different logic code paths.
Yeah, that's where a code coverage tool comes into play too, to make sure that you're, exercising every piece of your code.
So can you shift left if you test manually? If you haven't moved into automated testing, can you shift left?
Yeah, you can still shift left, and you don't have to have everything automated. Obviously, automation is going to make things go quicker, faster. When you get into a regression test, you're going to rely on your previous test cases to run your regression. And that's going to be a little bit more reliable because you've already kind of ran that test before. So there's a lot of things that automation, there's a lot of benefits to using the automation, but the shift left concept can be done with a manual approach if that's all you can do. Again, that's really looking at just testing earlier in that system development lifecycle. We try to make it easier with the automation and the tools that we provide, but you can certainly, use the shift left concept.
Yeah, just because you may not have the tool set to automate your testing, that's no reason not to shift left with your testing. You have to start someplace. And I still think if you shift left and you're manually testing, you're still going to go faster with better quality than if you wait to the end to manually test your application.
And there's a measure of risk for your application that you're testing also. So if you're like Flickr and you're deploying 12 times a day, if there's errors in that, it's probably not a high risk, right? People have pictures of their cats. Okay. But on the mainframe, we would deal with money. And you have a much higher risk. So can you do it manually? Probably. But, when you think about it as an insurance on a return on investment and risk, the higher risk, the more money you deal with in your applications, the more critical it is to your business, the more reasons it leans towards automated testing versus manual.
There's people that still do it manual, though. I was talking to a customer not too long ago, and we could see in their data, there's the advisor data, that it was taking them 21 days to do testing. And it took their developers 3 or 4 days to do the coding part, and they would have to turn it over to the systems guys who would do the testing. And that's what they always complained about. The developers were like, we're doing this quickly, and it's taking them 3 weeks. And then finally, when they had the data, the manager had the data in front of him, he's like, now I understand really what my developers are telling me, that this manual process is just not working.
So I think we've already covered it to some degree, but how does automation improve the shift left, and how can it be employed on the mainframe?
I think you have automated unit testing tools. So at BMC, we have the BMC CompuWare, Topaz for Total Test. It makes it easy to create your test cases. And then it makes it easy to automate those. And so as you're developing new features or fixing bugs in your code, part of the acceptance criteria, it should be that they create a unit test case, or they create a test case for that bug fix or for that new enhancement. And then that just goes into the inventory, and it gets added to the test cases that get executed on a nightly or a periodic basis as the testing gets done. And so, maybe you're using Jenkins and you put it right into your Jenkins pipeline. And so that every time that pipeline gets run, it runs all those tests as part of Topaz for Total Test. And then you'll see if something breaks, you will know immediately. Whereas if manual testing, you're depending on people to do the testing. People are good at what they do sometimes and usually, but they also miss things that computers don't miss.
Right. So for those who are looking to automate their mainframe software testing, what do they need to test? What kind of tests do they need to run? And what features should they look for in the tools that they're using?
Well, I think it's with Topaz for Total Tests, we make it kind of easy on developers. We can actually use tools that they already kind of are familiar with, like Expediter. They can run an Expediter session and automatically create that test case. So we make it pretty easy to collect, and then we can play back that test case. And like Spencer says, we can put that into an automation. So the speed at which we can create the test case is really important, because the more test case we can create, we're creating this larger test bed that we can run as a regression with the automation. So I've known that the shops I used to work at, where you might have fixed a bug, you have somebody that tests that program after they've corrected the bug, and then it gets put into production. If you don't have a regression where you run it on a nightly batch, or whatever the frequency is, that bug could come back. And now you have to kind of go back in and kind of recreate that test case again. Where if you have the automation, you can run that test case in a nightly regression and catch it, make sure it doesn't come back. So there's a lot of benefits to having the speed at which we can create the test case and then be able to put it into a pipeline and run it, like I say, nightly to catch any kind of future impact.
Yeah, the other thing is virtual versus non-virtual. Virtual allows the developer to test their code when other parts of the code may not be available, or other parts of the system. So for example, the database. So you can simulate those calls to the database or the read from the file with virtual testing. And that way, it really helps shift that testing left, right? Because they're testing immediately and they're not waiting for the rest of the application to be available or created.
How does performance testing fit in with shift left?
So performance testing, going back to my Strobe days, is that if you test with just a few records of data, I'm going to go a little bit against what we were talking about earlier, is that you really kind of want to put the load on the system or on the application to see how it performs. You might not need to test with a billion row table, but you should try and simulate as much of the real world as you can. You can do some of that testing earlier on. If you're using a product like Strobe, you can look at where the CPU is being consumed in the code. And, maybe you've coded something incorrectly, or you can code it a different way so it uses less CPU. But you really start to see the impact of how you're accessing your database, whether you're using, a table space scan to get the data, or you're using an index. And with a few records of data to DB2, it really doesn't make a difference whether it uses an index or a table space scan. It's going to perform equally well. I don't know, Steve, you probably have some insights into that better than I do. But performance testing, I think you should be looking to use more of a production set of data to really get the feel of how the application is going to perform.
So coding best practices come into play a lot, especially with DB2 SQL. And performance. And so you should have some kind of scanning mechanism or a team review to review SQL, review your packages, and do SQL tuning as part of your testing process. So you can run something that doesn't explain. It's a good idea to copy the run stats information from production into your test system, then do your binds and run and explain. So there's a lot of things that should happen in your performance testing, and especially to see if things change from release to the release. So definitely performance. I would also say network is often underappreciated in testing. So if your customers are using a web-based interface to the mainframe coming in through ZOS Connect or something like that, your test cases should try to duplicate that as close as possible, because network hops oftentimes are an issue. And oftentimes when you're doing a web-based, the engineers that built that didn't realize the table had a billion rows in it, and they're doing dynamic SQL, and it may not be efficient. So there's a lot of performance testing, and get your test as close to production especially off the mainframe, to duplicate network issues as possible. And as long as I'm talking about data, don't forget your test data management plan about your data. And if you're running your testing and it's a destructive test, which means you've updated your tables, so you just can't run it again, make sure that your automation includes unloading those tables, reloading those tables. If you have additional columns or indexes that you're running, make sure that your test management plan fits to your testing. And especially where you're updating data and you just can't run it over and over again. And a lot of times we see people provision a test environment, and then load the data into it, run the test, and then deprovision that environment. That is a very good solution to shift left, where you're not consuming a lot of resources and you're just letting the mainframe do what it does best, just crunch along and process data in an automated fashion. So as you're looking at your code paths, don't forget your data and your test data management plan.
Okay, I think we are out of time, but thank you everyone for joining us today. This is a great conversation. I certainly learned a lot. So Spencer, Paul, Steve, thank you for joining us.
Hey, thanks for having us, Matt. This was a lot of fun. We should do this more often.
And definitely do it. Improve your testing, improve your quality, move faster, and we'll keep the mainframe as a core part of our business.
Yeah,
definitely. I'll put some links for more information in the show notes, including a Forrester Total Economic Impact study that really underscores the benefits gained with automated testing and the return on investment. And don't miss our follow-up episode, in which we'll discuss new enhancements to BMC AIME and BMC CompuWare tools included in our October 2021 release. So thanks for listening, and until next time, take care. You're listening to The Modern Mainframe, BMC's intelligent Z optimization and transformation podcast, covering the latest trends and issues on the mainframe and how BMC AIME and BMC CompuWare solutions can help you build a mainframe-inclusive DevOps toolchain.